Hi, my name is Patrick Crampton-Thomas, Sales Director at IndX in Europe. So welcome to the fifth video in our series on SAP Digital Manufacturing. So in the last video, we looked at a test work center, but really using how we'd set it up and use manual processes. So today we're going to look at how we automate that. So how we can connect using MQTT, standard protocols, to measuring devices and test equipment to automate the test workstation. So today, Clara's going to take us through the details and the demonstration. So thank you very much and enjoy.
I am Karamas Garcia. I am functional consultant at IndX. During last episode, you could see the test work center board where all the activities were executed manually. And today we will perform the same activities of the testing operation, but for the workstation that has machine integration capability. But first, we will make a short introduction. Okay, so for this session, as I already said, we will do a small introduction and then a live demo directly on DM. So SAP Digital Manufacturing supports following communication protocols with manufacturing systems. We have proprietary protocols when shop floor environments have Honeywell or GE shop floor. Then we have REST, but it's slow for shop floor connectivity. Then we have OPC, that it's already explained in episode 3 by my colleague Shitish. You can go watch it if you have time and want to have more information about it. And finally, we have MQTT, that it's the communication protocol that we will cover during this session. So what's MQTT? Is a messaging protocol that enables efficient communication between devices, especially under limited bandwidth or power conditions. It works like sending a group message where a publisher sends data to a broker distributing it to subscribed devices. It suits IoT environments like smart homes and sensors designed for simplicity, reliability, and constrained resources. Now let's go a little bit deeper into how MQTT works. So this would be more or less what happens inside your automotive plant. So we are testing operation after the assembly. I will try to go through it in very simple terms. So we have in the center of the picture the MQTT broker. It's like a central hub or post office for all the messages in the testing area. So it does not decide what the message means. It does not modify the message. It only receives the information and sends it to the right subscriber. Then we have the testing machine as the publisher. So it publishes some information, like for example, in this test case, resource status, if the resource is productive, enabled, disabled, and also, for example, again, in this test case, some non-conformance codes of some part. It's like the testing machine is saying, here's my latest status, or here's the non-conformance code for this part. Then in the right part of the picture, you can see the subscribers. So one can be the MES system, in this case would be the digital manufacturing. And based on your test case, we will have also the quality system. Apart from this, we have a database storage for keeping all the information. So it can be stored all the statuses for all the different machines and all non-conformance codes for each part. So you can later ask questions like how many non-conformance codes did each machine produce last week, or how long did each tester was enabled, productive, or disabled. So if we put everything together to sum up, in your automotive testing scenario, you will have your part assembled and it will be sent to the testing operation, and the testing machine will publish some messages through MQTT. MQTT will receive the messages and it will send those messages instantly to DM. So if the piece is correct, then and passes all the tests, it will go to the next operation, that in this case would be packing. So after this small explanation, here you can see the difference between MQTT and OPC. You can take a look later on at this slide if you want to have some more information, and same with the MQTT benefits. To not make this session longer, you can take a look after the demo. So now let's go directly to DM, and we will record a productive downtime from MQTT. Also, we will create a non-conformance code from MQTT, and we will scrap the SFC. So in this case, a third-party MQTT server is used. It's a light client application used to simulate MQTT messages through MQTT protocol. And so MQTT uses a public API standard, and they're not attached to any specific protocol. To be able to receive MQTT messages, we need to do some configuration on DM. We need one of those configurations is create some specific production process for a specific action, and some other integration topics. Okay, so now we will just connect to MQTT, and we can see here the pod that we're going to use, that it's the test pod. Let me open it. Okay, let me look for the right. Here it is. Okay, so for example, we have there we had there all the list of long list of SFCs. We just selected this one, so the operator will go directly into the testing machine, and we'll see the previous screen, this one, and we'll select the SFC that wants to work on. So first thing that we want to introduce you is how to send some unproductive status to DM. So we can see the resource now is productive. So with MQTT, we will send the not productive status. Okay, so for each action, like for example, in this specific use case, we have to update, we're going to update the status and also to log some non-conformance to the SFC. We have to we need to have one specific topic to each of these actions. So for these resource status updates, we have this specific topic, and then we will have a specific query that needs to be introduced. Okay, so we can see that we will send to DM the unscheduled down status. Now let's just publish it, and it takes some seconds, but we will see directly in the pod that the resource turns to unscheduled down. Okay, now we can see it. Resource status unscheduled down. Okay, also this status was reported here. We can see unscheduled down. So all the different status that are not productive status are recorded here. Okay, now let's go back to productive status. So we need to update these. Okay, this is the same. Okay, now productive. So let's publish it. And now it's productive again. Okay, now let's start the SFC. And what I want to show you now is how to log non-conformances via MQTT. So we can see that this plugin to show all the different nonconformances locked for this SFC is empty. So now let's update the topic. So we have a different topic, it's this one. And now we will log the SFC. So we need to update also the SFC number, that it's this one. And we will publish this code that it's attached directly to script routing. So once we log the nonconformance code, it will appear into the nonconformance data tree plugin. And after we clicked on done, then the SFC will be automatically scrapped because the routine will be executed. So let's publish it. Okay, so we can see here nonconformance code logged via MQTT connection, and we can see it also here. Okay, so now let's just press done, and the SFC will be automatically scrapped. Okay, so after the SFC was scrapped, we can see directly on the SFC report that now our SFC is status scrapped, and the completed quantity is obviously 0. So also we can check directly on ERP, because this information is transferred directly to Esper, so we can check directly there also. So we go into the transaction. This is the order. And if we go to operations, testing operation, and to quantities, we can see that the confirmed scrap is 5, that it's the complete quantity of the SFC. So that was everything for today's session. Thank you so much for watching, and don't miss the next episode about the Reaper Work Center bot.